Imagine being an astronaut.
5 seconds. 4, 3, 2, 1.
Setting off to the International Space Station today. Travelling up to 250 miles above Earth and orbiting at about 17,000 miles per hour. You'd have an amazing view of the Earth rolling past beneath. But have you ever wondered about the technology needed to keep humans alive and healthy in space?
Okay, we checked all 4 systems.
In deep space, an astronaut would receive 50 to 60 times the radiation we do on Earth.
Contact with a test 1.
Any spacecraft carrying astronauts need windows for all sorts of reasons. And so creating next-generation radiation shielding glass is a really important part of allowing humanity to travel into and explore the reaches of space. Hi, I'm Dr Katrina Skerratt-Love. You can call me Kat for short, and my pronouns are she, her. I am a Royal Society Career Development Fellow, and my research is looking at more cost-effective lead-free glass used for radiation shielding purposes in space. When I describe to people about making glass, I would say it is kind of like making a cake. And what I mean by that is you start off with a bunch of dry ingredients, and then once I've precisely measured out these dry ingredients, I put them into a bag ready for when I mix them and then eventually melt them into a glass. And then I'll be putting it into a very high temperature furnace. So think about your oven times 100. And then when it's ready, what I'm then going to do is pour it and cast it. But rather than casting into a shape like you would a cake, I'm going to drop a massive piece of metal on top of it to splat quench it. And this makes the glass really, really thin and cools it down really, really quickly. And then we'll see what type of glass we're left with. Making glasses can be quite a creative process when you're trying to think about what goes in. So lots of different elements, you can add lots of different combinations that affect properties. So I'm adding bismuth oxide. I'm adding this for its radiation protection purposes. Maybe you're wanting a glass that is impact resistant, so it can resist being hit by, in my case, if it was in space, bits of debris floating around at high velocity. Maybe it'll melt at low temperature, which is what I'm interested in. So there's lots of different properties you can look at, and you can control that by changing what's in your glass and the quantities by which you add them. Okay, so my program is set and running. I'm going to take our little crucible. I'm going to pop it in here. And this is what it looks like before the elements heat up. And then we're going to close this up. So now we just sit and wait and let it cook. One of the most exciting moments I have with glass making, even after 7 years of doing it, is the moment when I take it out of the furnace. Because I don't know whether it's going to pour, whether it's going to flow, whether it's going to crystallize. The moment when I pour it and cast it or splat quench it, and then I look at my glass and I see that it's transparent and there's no solid bits in it, I'm like, yes, that's a win for the day. Another area of my research is looking at glasses made from different materials, and what I mean by that is extraterrestrial materials. So one of the things I have a real interest in is Martian regoliths, and Martian regoliths is essentially the raw materials that are available on Mars. What I'm currently working on is modelling compositions that could potentially be made into a glass. And the reason why this is important is if anyone on Earth is ever thinking of inhabiting other planets, we need to be able to have materials that can protect us from those environments which are very different from Earth. So on Mars, we need to be able to make our homes, and one of the things you could do is potentially make glass shielding material from that regolith, because you can't physically ship over the materials from Earth and fly it over to Mars, because that's just not economical at all. So therefore you use what's there. There's some research looking into, making bricks, for example. There's been research looking at the moon where they actually made optical fibers from lunar regolith. So it can be done, but it's not widely investigated at the minute.
Roger, you're on, sir, you're on.
School was challenging, I think is the best word to use, for lots of different reasons. Interestingly, I was actually terrible at maths. My forte was actually music, but I loved chemistry. did really well at my GCSEs. Then I got to my A-levels, took on far too many subjects, and I essentially flunked my A-levels for a number of different reasons, probably because I did too much, but also because I had undiagnosed dyslexia, undiagnosed autism, and I just couldn't write the essays. I didn't know why. But I was resilient and I got a place at my local university, Sheffield Hallam, doing materials engineering. It was a course I didn't even know existed, but it turned out to be the perfect course. I was, for a long time, the only girl on my course in my year. Probably was the only woman of colour, actually, in my course as well for the longest time. And I found my confidence and I found my voice again. I came to terms with my sexuality. I came out as queer. And then I kind of moved into industry. Yeah, I would say kind of progression-wise, things have kind of gone up. So getting this confidence, I want to share it with other people and share what I'm learning along the way to give them that confidence as well. Alongside my research, I have this other calling, which is mentoring people and providing a safe space for young researchers who are in some shape or form a minority. Whether that be people of colour, whether that people with disabilities, whether people that are queer, where all of the above I identify with. Because the best research that comes out is where you've got this community of people that are coming together with these different ideas from their personal experiences, who are coming in and thinking about the social factors, or people coming in thinking about the environmental factors. This is where you start to get the really interesting solutions to really complex problems. I think the world of research that I want is one that calls out the status quo, because research isn't always about the papers that you publish. It should be more about, like, what is it as a society we value that we want to be training young minds to do more than anything.